I hope everyone's doing well. I'm Mr. Rish. Thank you for joining me for this video where this reaction is the focus of it. What are we looking at? You're seeing here an alkene functionality and a cyclobutane in the presence of an acid, hydroiodic acid. What is the end result? Let's start with naming this. You know you have a cyclobutane, you have an alkene, which is 2 carbon, and ethene. Which of these will take precedence? This takes precedence. It's precedent over an alkane. This is carbon 1, this is carbon 2, this is cyclobutane. Once you've numbered it accordingly, the attachment is on the lower number. You can say it's 1 cyclobutyl, B-U-T-Y-L, and then ethene, E-T-H-E-N-E. You're not going to name it the other way around, where you're giving this the precedence. In which case you'll be saying 1, and then you can say, well, let's use the word vinyl, 1 vinyl cyclobutane, because this way it's wrong. Vinyl meaning this. Another name for this functionality is vinyl. 1 vinyl cyclobutane, meaning on the cyclobutane carbon 1 you have a vinyl group. This right here is wrong, this right here is right. This is right because the alkene is higher precedence than an alkane. You will name this as your parent compound and this as your attachment. 1 cyclobutyl ethene in the presence of hydroiodic acid. What are you going to see? You know you're thinking here about an addition reaction via a carbocation intermediate. Now what is the end result? Or let's say what is the expected result, or what are the possible end results? If you're looking here at this compound right here, the alkene, the pi electron or the pi orbital can behave in a nucleophilic manner, and it can do this. It can snatch the hydrogen and push the iodine away. When you push the iodine away, you're going to have that. What will be the other item? It will be this, but a bunch of different items can develop possibilities. One of which is this. Let's look over here. We have your cyclobutane. Then you can have CH, you can have here a carbocation develop over here, the hydrogen being snatched by this terminal carbon, and you have a CH3. Or you can say you have the other way around, where you have your cyclobutane over here, the first carbon attached that hydrogen and the carbocation developed over here at the end. You know, when you're looking at carbocations, the order of stability is tertiary is better than secondary, better than primary. But then even then you can bring in the other various types, allylic or benzylic, various resonance forms can develop. Those will be more stable than these. But here we're only looking at this because no resonance is possible with anything you see over here. Everything is saturated. Once these intermediates have developed, everything is saturated. What I see over here, only 2 possibilities, secondary and primary, from what I've enumerated for you. This is going to be more stable than that. So when you're looking at this in terms of stability, we have that. If you were to complete the reaction forward now, and then you look at the iodide coming, and it would be iodide because you would present it as this. It would be iodide. Why would it be? Because both of the electrons from this bond, hydrogen iodine bond, went to iodine. Both of those electrons went to here. Because you know when you're looking at hydroiodic acid, you're looking at a Lewis structure which looks like this. But both of these electrons came into iodine, and hydrogen went away as a proton, no electron. This kept both, hence you're seeing it in that form. So you're seeing this. What are the end results? The end results will be what you would expect. You have here your cyclobutane, and then you have your iodine or iodide attaching here, the iodine atom, but the iodide anion coming over here. Or you can have the cyclobutane as you see over here, and then you have CH2, CH2I. You know this right here is going to be more preferred than that, but this is only us looking at a very narrow perspective. We can have yet another perspective come about, because I already told you tertiary carbocation is more stable than secondary, more stable than primary. If what I've put for you over here were the only 2 products which were possible, then this right here would be your end result. You would call this, based now with the cyclobutane having the precedence and this having the secondary precedence. How would you name this? You would have here, you have an ethyl attachment. You would say 1 iodoethyl cyclobutane. And that's how you can name it. On the ethyl functionality, you have carbon 1 of that, you have iodine, but it's all attached to cyclobutane. 1 iodoethyl cyclobutane. And you can name that. and this would be your expected result. But again, I'm telling you there's another possibility, and that would actually be the predominant result. What would that be? We've seen this right here is very low. I'm just going to cross it out. This right here is possible, but there's another expected result, and let's examine that. The other expected result is one which is going to develop a tertiary carbocation. We've seen over here secondary and only primary carbocations come through. How is a tertiary carbocation going to come? Look over here. When I have this CH with the carbocation over here, and when I have this, the two intermediates I've already shown you, this right here is my primary carbocation, this here is my secondary carbocation. This we've already told you it's not relevant because the primary carbocation is not very stable. But we can have something develop from here. What will that be? Show your structure here in a more enhanced format. You know this right here will have a hydrogen because you have a carbon over here with 3 attachments. You have one here, one here, one here, but then there's actually a hydrogen because then it has a valence of 4. That's what you're seeing over here. Then you have this carbocation over here, and then you have CH3. What you will have over here is something called a carbocation rearrangement or a hydride shift. The hydrogen will shift over here, bringing the carbocation over here, and this is what you will have develop. The carbocation has come over here, and now you've gotten a CH2 and you've gotten a CH3. Now we're looking here at a tertiary carbocation. This right here is the most stable carbocation, not the secondary or the primary as I've shown you. Why is this more stable? Because when you're looking at a carbocation, it represents a charge deficiency. The more alkyl groups you have, because alkyl groups are generally electron donating towards a carbocation, the more of these you can have towards it, the more stable it is. I have one coming from this direction, one from here, one from here. This is more stable. Tertiary is more stable than secondary than primary because these electron donating groups stabilize an area of charge deficiency by donating inductively part of their charge. Now when you attack this with your iodide anion, and you know it looks something like this, it's going to attach over here. When it attaches over here, you've got an iodine here and you've got a CH2, CH3 here. This is what you have. Now how would you name this? This right here is your major product, expected product, because of the tertiary carbocation intermediate being most stable after the hydride shift that you saw. The hydride shift, we can say HYDRIDE hydride shift, or you can say hydrogen shift, either or, it's fine. How would you name this? You're looking here at a cyclobutane, which is your parent compound. Everything is attached to it. You can say 1 iodo 1 ethyl, but you can say it better in an alphabetical manner. 1 ethyl 1 iodo cyclobutane. That would be the preferable way of saying it. 1 ethyl 1 iodo cyclobutane, because you're looking at the alphabetical order. Another way you can just say it in a more condensed manner is this. You can say 1 comma iodo ethyl cyclobutane. The only reason why here I'm putting the iodo first before ethyl, even though of alphabetical, because I'm making this all one large name. It reads better, it's more smooth. Iodo ethyl is more smooth than saying ethyl iodo. 1 iodo ethyl cyclobutane, meaning on this carbon 1, I have 2 items, 1 iodo ethyl cyclobutane, but a preferable name ideally would be 1 ethyl 1 iodo cyclobutane. This right here is your major end result for this reaction you see over here, because of carbocation rearrangement developing from that phenomenon that you see over there. Thank you for watching.